Hi everyone, today we're going to study the parabola with vertex at the origin and opens downward. First, let us define parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Let us now draw a parabola that opens downward. Here we have a line and a point. The point is called the focus, and the line, which is horizontal, is the directrix. In here, we put the line above the point. Now let us find points that satisfy the condition of parabola. It means those points that are equidistant from this point and this line. The first point that we can consider is the point between this point and this line. And here is the point. Let us find more points. Here we have two more points equidistant from this point and from this line. Here are four more points that satisfy the condition of parabola. And from here, let us connect these points with a smooth curve. And here we have the parabola. And intentionally, we put this point at the origin. There is a line perpendicular to directrix and passing through focus that is called axis. This is the axis. And in this example, the axis is the y-axis itself. So we have this equation x equals 0 for the axis. This is now a parabola with vertex at the origin, that is 0, 0, and opens downward. We let A be the distance from the vertex up to the focus. So it means to say the coordinates of focus is 0, negative A. The distance from this vertex to the line is also A. So the equation of the directrix is y equals A. There is a chord drawn perpendicular to axis and passing through focus that is called latus rectum. This is the latus rectum. Let us now derive the formula. Let us pick a point of the parabola. Let's say this point. Let us name this as P with coordinates xy. And this P is a moving point representing all the points of the parabola. Now, let us get the distance of this moving point away from the focus. And we denote this as d sub 1. Also, the distance of this moving point away from the line, which is the directrix, we denote this as d sub 2. By definition of parabola, we say that d sub 1 is equal to d sub 2. Take note that d sub 1 is the distance between 2 points. So we will use the formula for distance between 2 points. So we have now the big square root of this x minus 0, and it is squared, plus y minus the negative a, which is also squared. And this is equal to d sub 2. Our d sub 2 again is the distance of this moving point away from the line, and this is a perpendicular distance, and the distance is a minus y. Let us simplify this equation by squaring both sides. If we do that, in the left side, the big square root is cancelled out. So we have now x minus 0 will just be x, and it is squared, plus the y minus negative a becomes y plus a, and also squared, equals the a minus y is now squared. Let us expand the squares. So we have now x squared, we'll just copy that, plus this square of y plus a becomes y squared plus 2ay plus a squared, equals the right side is the square of a minus y. So we have now a squared minus 2ay plus y squared. We can see here that there is y squared on the left side and y squared on the right. So we can cancel these terms. Also, there is a square on the left and another a square on the right that we can cancel. So what remains now on the left side is x squared, and this positive 2ay we will transpose on the right. So we have now, from positive, it becomes negative. So the right side is this negative 2ay is now copied here, and minus 2ay. Combining the terms of the right side, we have now negative 4ay. So it means to say, we have now the equation of parabola with vertex at origin and opens downward. This is now the equation. Let us now substitute y equals negative a to get the coordinates of endpoints of latus rectum. Remember, this is the latus rectum. So this equation now becomes x squared equals negative 4ay, and the y becomes negative a. This negative and negative becomes positive, and a times a becomes a squared. So we have now here x squared equals 4a squared. Let us get the square root of both sides. So we have square root of x squared equals the square root of 4a squared. On the left side, we can cancel the radical and the square. So only x comes down, and this is equal to plus or minus 2a. Therefore, the endpoints of latus rectum are the points 2a, negative a, that is the point, and negative 2a, negative a, and this is that point. By this graph, we can deduce that the length of latus rectum equals 4a. And this 4a we can directly see from the equation of parabola. We'll just take the positive value of the coefficient of y. Let us see this example. Sketch and discuss x squared equals negative 12y. For our solution, we can see that this equation here falls under the pattern of our parabola with vertex at origin and opens downward. So that is x squared equals negative 4ay. We will take the positive value 4a, and this is equal to that value 12. This 12 here is the length of latus rectum. We can solve for a by dividing this equation by 4. So the value of A equals 3. And from here, we can now write the coordinates of focus, and that is 0, negative 3. Also the directrix, which is y equals 3. The axis is directly our y-axis with the equation x equals 0. Given the focus and directrix, along with the vertex at origin, we can now draw our parabola. This is now the parabola that opens downward and vertex at origin. The focus is here. We have the directrix above. And we can now write the endpoints of latus rectum, and this is our formula. Plus or minus 2a, that is the x coordinates, and negative a for the y coordinate. So the points are 6, negative 3, this is the point, and the negative 6, negative 3. This is the other endpoint. This is now our final answer. I hope you learned something from this video. See you again next time.